Welcome, Algebra 1 students, to another Regents review video. This is the Algebra 1 Common Core Regents exam, June 2014. These are going to be the solutions for the open-ended response, parts 2 through 4 of the Algebra 1 June 2014 exam. Before we begin, just a quick reminder, please do not cheat off of these questions and do not hand them in for homework. Please try the problems on your own, and you will see yourself really succeed on this exam if you really try the problems. I promise you that. I've been doing this for a long time. I'm telling you that it will happen. And just from my own personal experience from taking Regents exams, that this is the way to do it. Please hit that subscribe button down below and make sure that you visit my website at www.nysmathreadersprep.com for more math material. And please make sure you have a TI Nspire CX or some sort of graphing calculator, but the TI Nspire CX preferably, because I use that calculator and it is quite an amazing tool. Without further ado, part 2 through 4. All right, here we go. We're going to start off with question number 25. Now, I want you to be a smart test taker. The part 2s are supposed to be quick, they're supposed to be fast, and they're supposed to be done within 5 minutes each. No more than 5 minutes. So let's go ahead and give this a try. Draw the graph of y equals the square root of x minus 1 on the set of axes below. So first and foremost, you're going to go to your calculator, and you are going to graph that function. So control square root of x, make sure that you escape out of the square root, minus 1. All right, and there it is. Now, what's nice about the calculator is if you do control T, they tell you the values. But the problem is there's like some really disgusting values in here. So what I want to do is I'm going to be smart, and I'm going to say, all right, you know what? I'm going to use my whole numbers. So I'm going to graph 0, negative 1. All right, so I know for my x and y table, I'm going to be graphing 0, negative 1, 1, 0, right? And then I saw some values that are whole numbers. See, like right over here, 4, 1, that's a whole number. So 4, 1, and 9, 2. So now I'm just going to go ahead and graph it. 0, negative 1, 1, 0, 4, 1, 9, 2. Draw your graph with an arrow at the end, and make sure that you label y is equal to the square root of x minus 1, and you are done with that question. Easy 2-point question. Nice and easy. Graph it and be done. 26. The breakdown of a sample of a chemical compound is represented by the function p of t equals 300 times 0.5 raised to the t power, where p of t represents the number of milligrams of the substance and t represents the time in years. Whew, a lot of reading. In the function p of t, explain what 0.5 and 300 represent. Okay, so what you have to know is what the formula represents. P of t is equal to 300 times 0.5 to the t power is derived from the formula a of t is equal to the principal times 1 plus or minus the rate raised to the t power. Remember that your p is your principal, or your starting amount. Your r is the rate of increase or decrease as a decimal, expressed as a decimal, and t is time. Okay? So what does 300 represent? Well, you need to say that 300, no, I'm sorry, let's do 0.5 first because they're asking for 0.5. So 0.5 is the decay rate. It's decaying because, first of all, if you plug it into your calculator and you just graph it, 300 times 0.5 raised to the x power, it's, okay, where did it go? Oh, I'm sorry. I should have graphed 300, my apologies. Okay, there it is. No, why is it? Sorry, that 300 is supposed to be outside. Why is it doing this? 300. That's better. That's exponential decay. So, we know that 0.5 represents the rate of decay each year. Okay, so that's your first answer. And 300 represents the starting amount. The starting amount of the substance. And that's all there is to it. Pretty simple question. 0.5 represents the rate of decay, and 300 represents the starting amount or the initial amount of that substance. All right? And that's how you do question 26. Moving on. 27. Given 2x plus ax minus 7 is greater than negative 12, determine the largest integer value of a when x is equal to negative 1. Okay. Ignore this for a moment. We're actually going to get back to this, but the first thing that you need to realize is plug in negative 1 for x. So you take your 2x plus ax, oh, my apologies. You take 2x plus ax minus 7 is greater than negative 12, and you plug in negative 1 for x. So 2 times negative 1 plus a times negative 1 minus 7 is greater than negative 12. Great. Negative 2 minus a minus 7 is greater than negative 12. I'm going to combine like terms. Negative a, negative 2 plus negative 7 is negative 9 is greater than negative 12. Add the 9 on both sides. We get negative a is greater than negative 3. And then we're going to divide by negative 1. And remember, when you divide by a negative, you have to flip the inequality sign. So your answer is a is less than 3. Okay? But we can't just stop there. It says determine the largest integer value. Well, the next largest integer that would make this work has to be 2. A has to be 2. So the next largest integer is x is equal to, sorry, not x, a is equal to 2. Because you're only going down. You're only going down because a has to be less than 3. So that means the integer values are 2, negative 2, 1, 0, negative 1, negative 2. Keep on going down. 2 has to be the highest one because 3 is not included. And that is how you do this question. Sorry, my head was probably in the way just now. So I am going to move that up here just in case you missed it. Where am I going to move it? No, I'm going to move it up here. There we go. The next largest integer is a is equal to 2. All right. Moving on to question 28. 28. Here we go. The vertex of the parabola represented by f of x equals x squared minus 4x plus 3 has the coordinates 2, negative 1. Explain the coordinates of the vertex of the parabola defined by g of x equals f of x minus 2. Explain how you arrived at your answer. I'm going to show you 2 ways to do this. I'm going to show you the algebraic way, and then I'm going to show you the graphic way. First and foremost, you need to know your horizontal, vertical, all your transformation rules when it comes to quadratics. When you have a number inside of the parenthesis, this is going to be always a horizontal shift. And it is always opposite the sign, okay? So if they're telling you that f of x has the vertex 2, negative 1, and it's a horizontal shift opposite the sign, how many units to the left or to the right are we going? Well, we are going to the right by 2 units, all right? 2 units. Because if this is negative, you would think to go to the left, but we're actually going to the right by 2 units. So your new coordinate, so you're going to say that g of x has the vertex of 4 comma negative 1. The reason why it's 4 is you're taking the 2 and you're adding 2 x units to the right. All right? And you could just say that this was determined, because it says explain. So this was determined by adding 2 to the x value of the vertex of f of x due to a horizontal shift. Now I'm going to show you how to graph this on the calculator. This is an awesome tool. You cannot do this on the TI-84. That's why I'm suggesting that you buy this one. So, f of x. If you graph x squared minus 4x plus 3, you get that function. Now, what's awesome about this calculator is that if you actually type in, now you see how this is stored in F1? it's bolded as F1. If you type in F1 and then followed by a parentheses x minus 2, it will actually perform the transformation for you. And look, it's going to the right by 2 units. So that's how you could easily determine your vertex. If you do menu, analyze graph, minimum, and click on the blue graph and click, that's 2, -1, and do it again. Menu, analyze graph, intersection. No, I'm sorry. Menu, analyze graph, minimum. Click on the red point, and then what is going on here? Click. My apologies. I don't know what. I think it selected the blue graph by mistake. There we go. Click, and there is your minimum point for -1. So you could either graph it or you could just solve it algebraically. So either one is perfectly fine. All right, moving on to question number 28. On the set of axes below, draw and graph of the equation y is equal to -3/4 x plus 3. And what we're going to do right now is just basically draw this. So, sorry, my dog is barking upstairs. So, m is equal to -3/4, and b is equal to 0, 3. That's your slope, and that is your y-intercept. So, we're going to go ahead and graph this. Up 1, 2, 3. Down 3 to the right 4. Down 3 to the right 4. And then to go in reverse, you just go up 3 to the left 4. And then up 3 to the left 4. Now what I'm going to do is I'm going to graph my line, just like so. Oh, shoot. I did that by mistake. I do that all the time. Darn it. Okay, so I'm going to draw this line, and I'm going to label it. Y is equal to -3/4 x plus 3. Okay, so that will give you 1 point. That's great. Now it says, is the point 3, 2 on a solution to the equation? Explain your answer based off the graph. So is it a solution? Well, plot the point 3, 2. 1, 2, 3, 1, 2. Is that point 3, 2 a solution? No, it's not. So in your answer, you were going to say no, because the line y is equal to -3/4 x plus 3 does not cross that point as shown in the graph. And that's all you have to do with that question. Pretty simple stuff. Not too bad. All right, question number 30. The function f has a domain of 1, 3, 5, 7, and the range is 2, 4, 6. Could f be represented by 1, 2, 3, 4, 5, 6, and 7, 2? And it says justify your answer. So what we're going to do is determine this to be a function. Is this a function? No, it's not. Because the reason why this is not it is a function. Why am I saying no? It is a function. Because we have 1, 3, 5, 7. So that means that your x values are not repeating itself. So could this be represented by this? So we could say yes. F can... Why? I'm writing 10 times faster than usual. F can be represented by the set above because there are no repeating x values in the set. And that's all you need to write, because if it doesn't have x values that, well, if all these x values, in this case 1, 3, 5, 7, if all of those x values are non-repeating, the function, or f, could be a function because it passes the vertical line test. Now, your answer could be any one of those. It could be this, or you could say because it passes a vertical line test, either one of those is perfectly fine. Moving on to question 31. Factor the expression x to the 4th plus 6x squared minus 7 completely. So, what we're going to do is factor by the AM method. What adds to 6 and multiplies to give you -7? Well, that will give you X squared and x squared. Remember that you set up your double bubble. What adds to 6 and multiplies to give you negative 7? That's minus 6 and minus 1. Now, when it says factor completely, the chances are it's more than one step, because otherwise it wouldn't say factor completely, they would just say factor. So factor completely, there's another step somewhere, and that is right here. You need to factor x squared minus 1 by the difference of two perfect squares. So that will become x squared minus 6 carries along for the ride. That will become x plus 1, x minus 1. And that, ladies and gentlemen, is your answer to that. No. Oh, I'm sorry. That, okay. This negative 6 shouldn't be here. My apologies. That should not be negative 6. I sincerely apologize. That should be positive 7. My mistake. That should be positive 7. Okay, because 7 times negative 1 gives you negative 7, and 7 plus negative 1 gives you 6. Sorry about that. All right, moving on to question 32, the very last part 2 of this exam. So it says Robin collected data on the number of hours she watched television on Sunday through Thursday nights for a period of 3 weeks. I'm sorry, I just watch television. I don't analyze what I watch. The data are shown in the table below. Use an appropriate scale on the number line below to construct a box plot for the 15 values. Okay, did you know that you could actually put these values in your calculator? It's pretty awesome. You could put these values in your calculator just by going to your TI Inspire, go to your lists and spreadsheets, and I'm going to call this TV data, I guess. I don't know. And I'm going to type in all these values. 4, 4.5, 4, 3, 5, 3, 3.5, 2.5, 1, 2, 3, 1.5, 2, 1.5, and then, 2.5. Okay, so all these values, if you plug it into your calculator, and then you could either do one of two things. You could either go to Control Doc. I'm going to add a data and statistics page. This will wow your brain. If you click the bottom on your calculator using the hover pad, if you click the bottom and you click on TV data, it lines up all these points for you. Now watch what happens. Go to Menu, go to Plot Type, and then click on Box Plot. And look at this. Ta-da! It draws a box plot for you. Now you can just take your cursor and then hover over. That's your minimum of 1. Quartile 1 is 2, median is 3, quartile 3 is 4, and the maximum is 5. So what you are going to do is you're just going to take this line here, and you're just going to plot those values. So you have 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, and then 5.5. So your minimum is 1. Plot the 1. Your first quartile is 2. There's your 2. Quartile 3 is 3. Your median is 3. And your quartile 3 is 4. And your maximum is going to be 5. So now all I'm going to do is I'm just going to connect these lines. That's an ugly box plot. But it is what it is. And this, ladies and gentlemen, is how you construct your box plot. And that's about it. Now, if I were you, I would indicate on the left-hand side that your minimum is 1. Your quartile 1 is 2. Your quartile 2, which is known as your median as well, is 3. Your quartile 3 is 4. And your maximum is going to be 5. That's just taking your data from the calculator and showing the reader of the exam or the grader that say, hey, I put this in my calculator and this is what I got. So that's perfectly fine. Or if you did it by hand, good for you, because I used to do it by hand when I was in Algebra 1. I didn't have these calculators when I was in Algebra 1. Anyway, number 33. Write an equation that defines... Oh, these are the part 3s. Write an equation that defines m of x as a trinomial where m of x equals 3x minus 1, 3 minus x plus 4x squared plus 19. So, your job is to simplify this to a trinomial. So, m of x is equal to 3x minus 1, 3 minus x, plus 4x squared plus 19. Okay? So you are going to distribute these. Remember that you're trying to simplify this as much as possible. So you get, 3x times 3 is 9x minus 3x minus 3 plus x plus 4x squared plus the 19. And that is all equal to m of x. Now I'm going to combine like terms. 9x minus 3x plus x, that is going to be, let's see, that's going to be 7, no. Hold on a second. 9, 8, 7, 6. 3x squared. Oh, I'm sorry. That should be a 3x squared. My apologies. 3x times negative x is negative 3x squared. So the 9x plus x is going to be 10x. The negative 3x squared and the positive 4x squared, that's going to be positive x squared plus 10x plus 16, because that negative 3 plus 19 gives you 16. So this, ladies and gentlemen, is your simplified trinomial. Now it says solve for x when m of x equals 0. In other words, set this equation equal to 0 and factor and solve for x. So we have x squared plus 10x plus 16 is equal to 0. What adds to 10 and multiplies to give you 16? Well, those are just the numbers x plus 8, x plus 2 equals 0. 8 times 2 is 16, and 8 plus 2 is 10. Now I'm going to t-bar it. X plus 8 equals 0. X plus 2 equals 0. You're going to subtract the 8 on both sides. You get x equals negative 8. And subtract the 2 on both sides, and you get x is equal to negative 2. So your x values are, oops, I'm going to move that because my big head is in the way. So x is equal to negative 8, comma, negative 2. And that is going to be your answer. All right. 34, question 34, which is the next question, is one of the most interesting questions I've seen. And, you know, you really need to be careful with what you're doing here. Let me read it to you and explain what's going on. A rectangular garden measures 12 meters by 16 meters, is to have a walkway installed around it with a width of x meters as shown on the diagram below. Together, the walkway and the garden have an area of 396 square centimeters. So this is what they're saying here. This, ladies and gentlemen, in the middle that you see right here, this is your garden. Okay? So I'm just going to put this as green because gardens are green. So this is your garden. Okay? They don't tell you what the area of the garden is, and honestly, we don't really need it. We need the area of the big thing here. This blue piece that you see here, all of these blue markings, I guess that the owners of the garden, they want to install a walkway. So this blue section that you see here is the walkway of the garden. Okay? So all that is the walkway. So they're saying to us that the area of the whole thing with the blue plus the green is equal to 396. Write an equation that can be used to find x, the width of the walkway. So you have to be really, really careful here. Look at this. This is 16 meters, but the whole thing is going to be 16 meters plus 1x and 2x. Ladies and gentlemen, that is your length. It's your length of the garden plus your two sides of the walkway. Now the vertical one, which is up and down, the vertical one, that's just going to be, or your width, that is going to be 12 meters plus this x and this x, which is 2x. So your width is 12x plus 2. That's the area of the whole garden. Now the area can be expressed as, remember, length times width. So the area can be represented by length times width. The area, which is actually 396, so I'm going to replace this with 396, is equal to 16 plus 2x times 12 plus 2x. And that, folks, is the equation that can be used to solve for x. All right? And that is how you do the first part of this question. Now, the second part of this question says, describe how your equation models this situation. So you just have to basically explain why you did what you did. So I said the garden and the walkway have a combined area of 396 square meters. All right, the garden in its entirety is 16 meters plus the 2 walkways, which is your 2x. So the garden in its entirety is 16 meters plus 2 walkways long and 12 meters plus 2 walkways wide. And that is how you basically describe how the equation models the situation. I really don't like when they say those questions because, like, what are you going to put? I mean, this is probably the best answer that you could put. And then it says determine and state the width of the walkway in meters. So your job is to take your equation and actually solve it. 12 plus 2x. 396. Okay, so what I'm going to do is I'm going to distribute the first, outer, inner, last. So we get 192. Oh, I'm sorry, that shouldn't have an x next to it. It's just 16. 16 plus 2x. So you have 192 plus 32x plus 24x plus 4x squared is equal to 396. If you move the 396 over, you get 4x squared plus 50 plus 56. X minus 204 is equal to 0. Now from here, you could use the quadratic formula. The reason why we could use a quadratic formula is we cannot factor this. Actually, can we do it? I mean, we probably could take out a GCF, but I like the quadratic formula anyway. Actually, you know what? No, let me try this real quick. Let me see if 204 divided by 4. All right, 204. All right, so 56 divided by 4. Okay, so you could use a quadratic formula or you could use basic factoring. So if you actually pull out a 4, you're left with x squared plus 14x minus 51 equals 0. Now, to determine what adds to 14 and multiplies to give you negative 51, that is just going to be, I believe, if you take negative 51 and divide it by 3, I think that works. Yeah, negative 17 and 3. Yeah, so you get x plus 17, and you get x minus 3, and set that equal to 0, because 17 plus negative 3 is positive 14, and 17 times negative 3 is negative 51. Now we t-bar x is equal to negative 17, and x is equal to 3. Now, what we do is we reject the negative 17 answer because you can't have negative 17 as a length measure. You don't have negative feet. So it has to be x is equal to 3. So they're asking you now the width of the walkway. Well, the width is represented by the letter x. So since x is 3, we can now say that the width of the walkway is 3 meters. And that is how you do that question. All right, moving on to question 35. Almost done with the part 3s. The part 3s take a little long. Not going to lie. All right, Caitlin has a movie rental card worth $175. After she rents the first movie, the card's value is $172.25. After she rents a second movie, the value is $169.50. After she rents a third movie, the card is worth $166.75. Why in the world are they telling you this? They are telling you this because this is a linear function. Linear function. Linear lines, decreasing slope. Okay. Assuming the pattern continues, write an equation to define a of n. the amount of money on the rental card after n rentals. Okay, so all you're going to do is you're just going to do a of n is equal to, now, the initial amounts. How much do you have on that card to start with? Well, it's $175, okay? Minus, well, how much is it decreasing by? Well, 175 minus 172.25, that gives you $2.75. So it's decreasing each time by $2.75 times the amount of rentals. So this is the equation. Each part of it, the 175 is the actual rental card amount, and the n number is the amount of rentals. Okay? Amount of rentals. And the $2.75 is the price per movie rental. So each time you rent a movie, it costs you $2.75. Okay, so now it says here, the second part, it says Caitlin rents a movie every Friday night. How many weeks in a row can she afford to rent the movie using her rental card only? Explain how you arrived at your answer. So what we're going to do is we are actually going to take this equation and make an inequality. 175 minus $2.75 n has to be less than or equal to the number 0. Why are we doing this in the first place? Well, we are doing this to determine the maximum number of weeks she could afford to rent a movie. We're just going to solve for n right now and watch how this works. I'm going to add $2.75 times n on both sides. And what we're going to do is we are actually going to solve for n. So 175 is less than or equal to $2.75 times n. Divide by 275 on both sides, and we get 60. I'm not going to put it over there. We get 63.6363, and these are all repeating, is less than or equal to the number n. Great. So what does that even tell us? Well, she could only rent 63 weeks. Only rent 63 weeks. So that means, even though that it's 0.6363, that means that she has to rent for 67 weeks, which she can't do. So she could only, so what she'll have is she'll have some money left over on the card, basically. So Caitlin, oops, keep on spelling Caitlin. There we go. Caitlin can rent 63 weeks in a row. That's a lot of weeks. 63 weeks in a row because anything above 63 weeks will exceed the rental card amount. And that, ladies and gentlemen, is your answer to that question. That is your explanation, and that is how you do the work. All right, moving on to question 36. Oh, jeez, this is going to take forever. 36. An animal shelter spends, this is a long Regents, an animal shelter spends $2.35 per day to care for each cat and $5.50 per day to care for each dog. Pat noticed that the shelter spent $89.50 caring for cats and dogs on Wednesday. Write an equation to represent the possible number of cats and dogs that could have been at the shelter on Wednesday. So here's what I'm going to do. I'm going to let C equal the number of cats, and I'm going to let D equal the number of dogs. Okay? Now I'm going to create an equation. So it is, now just real quick, just to keep this in mind for your own purposes, $2.35 is for each cat, is the cost for each cat, and $5.50 is for each dog. So let's go ahead and plug it into an equation. So we get $2.35 times the number of cats taken cared for plus $5.50 times the amount of dogs, and that is the total amount, or equal to the total amount of $89.50. Ladies and gentlemen, that is your equation to represent the cost of dogs and cats on Wednesday. Now, Pat says that there might have been 8 cats and 14 dogs at the shelter on Wednesday. Are Pat's numbers possible? Use your equation to justify your answer. So basically what we're going to do is we're going to take the number 8, plug it in for C, take the number 14, plug it in for D, and see if that equals 89.5. So we get $2.35 times the number of cats, which is 8, plus $5.50 times 14 dogs. Is that equal to $89.50? Well, if we plug these into your calculator, you are going to get $18.80 plus $77. Does that equal 89.50? And if you combine these, you get $95.80 does not equal $89.50. So are Pat's numbers possible? We are going to say no, because having this arrangement of animals on Wednesday produced a monetary amount, meaning that it costs money, a monetary value of $95.80, not $89.50. And that's how you basically explain your answer as to why those numbers can't work. Okay. The very last part of this question is just a system of linear equations. Later, Pat found a record showing that there were a total of 22 cats and dogs at the shelter on Wednesday. How many cats were at the shelter on Wednesday? So what you're going to do is you're going to take the number of cats plus the number of dogs and set it equal to 22, because there's 22 total animals. Then you take $2.35 times the number of cats plus $5.50 times the amount of dogs and set it equal to $89.50. So now from here, what we are going to do is we're trying to solve for the number of cats. So I want to multiply the top by negative 5.50 to cancel out the D's, because I want to solve for C. So we get negative 5.50C minus 5.50D. That is equal to negative 121. And then we're just going to recopy this down here. Goodness, this is a long question. Okay, the D's cancel. And from here we get negative 3.15 cats is equal to negative $31.50. Divide by negative 3.15. Divide by negative 3.15. And we get C is equal to 10 cats. So your answer is there were 10 cats on Wednesday. Ladies and gentlemen, that is your answer. Now, real quick, what I want to do is I want to show you a nice, clever way, again, to plug this into the calculator. So if you go to your calculator page and you go to Menu, Algebra, and Solve System of Linear Equations, we're typing in 2 systems and click OK. You could actually type in your equation. So x plus y equals 22. And I know that I used C and D here before, but I mean, I could, but I need to change these letters in the bracket. Actually, you know what? Let me do that right now. I'm going to change this to C and D, just to make it a little bit easier for you. So I'm going to change this to C plus D equals 22. And then we get $2.35 C plus $5.50 D, and that is equal to $89.50. And look here. There were 10 cats on Wednesday and 12 cats on Wednesday as well, but they're asking for cats, so it is going to be 10. And that's your answer. Moving on to the very final question of this exam, finally. A company is considering building a manufacturing plant. They determine the weekly production site cost at site A to be A of x equals 3x squared, while the production of cost at site B is B of x equals 8x plus 3, where x represents the number of products in hundreds and A of x and B of x are the production costs in hundreds of dollars. Graph the production cost functions on the set of axes below and label them site A and site B. So what you have to do is actually graph these in your calculator. Now, just to save some time, and I hope that you can graph these in your calculator with no problem. Let me just quickly do this. I'm not going to pull up my table of values. I'm just going to show you how to graph these. 8x plus 3. And we get those values, these functions. I'm actually just going to tell you what the table of values gave me because this is taking forever. So this is site A. That's your 3x squared. 0, 0, 1, 3, 2, 12, 3, 27, and 4, 48. Remember that we are in quadrant 1, folks. We're only doing positive numbers, 1, 2, 3, and 4. So it has to be in quadrant 1. Now site B, the x and y coordinates are 0, 1, 2, 3, 4, 3, 11, 19, 27, 35. So now what I'm going to do is I'm going to graph these on my graph page. Cool. I'm going to graph the green one first. So it starts at 0, starts at 0, 0, goes to 3, then it goes to 2, 12, then it goes to 3, 27, 20, 22, 24, 26, 27, and then 4, 48. 48. Alrighty. So now I just connect these points. I cannot connect these for my life. That is so ugly, but that'll do. All right, so that is A of x. Now B of x is, let's see, 0, 3, 1, 11, 2, 19. Now since this is linear, I'm just going to use a line for my graph for the tool. Ooh, at 327 it intersects, people. You think that they're going to ask a question about that? You bet they are. And then 435. 435, 30, 32, 34, 35. Okay, so I am then going to graph this line. Purple. That is too thick. Okay, so this is B of x. That's site B of x. So now we're done with this. Now, if you really want to be very particular about your answer, you can circle this and put that as SS for solution set. So now let's go ahead and take a look at the follow-up questions, because of course they are going to ask us follow-up questions as they normally do. Okay, so that's how you graph those functions. Let's go ahead and see what questions they have in store for us. So it says, state the positive value or values of x for which the production costs of the two sites are equal. I said it. So you're going to say that the value of x where the two sites equal is at x equals 3 because the functions intersect at that x value. You could also say also at this value both sites are producing 300 products. That could be fine as well. All right, then it says if the company plans on manufacturing 200 products per week, which site should they use justify your answer? 200 products per week. Probably A of x, probably site A, because site A is increasing at a faster rate. So we are going to say here, we're going to say site A because the cost of... Wait a minute, I just said site A, right? Yes. Wait, it's saying in 200 products per week. Okay, well, actually... Hold on a second. Site B. Or site A. Okay, so if we go to Control T, and we go... Alright, there's no way that I can do this that quickly. So if you go down to 200... Now, don't do this on your calculator, because that's just ridiculous. You could actually plug it in by hand. Site A is definitely the best bet because it costs them less. So we are going to say as our answer, so we're going to say that site A, because the cost of producing 200 products is $7,000 less than producing the 200 products at site B. And the reason why you could justify that is if you go to your calculator and you type in F1 of 200 and then you type in F2 of 200, which is in your calculator, oh, I'm sorry, those are the number of products. So the cost, because it's saying the cost in hundreds of dollars. Yes, that would be correct. So site A, the cost of producing 200 products is $7,000 less than producing the 200 products at site B. And that is basically how you do those part 2 questions. All right, that's the conclusion of this video. Make sure that you hit that subscribe button down below, and make sure that you visit www.nysmathregionsprep.com for much more math content in Algebra 1, and I'll see you soon.